Okay, that's good. Let's have a class. And I'll use a zone here also to record. So we will see what's going on. So I have a zone here. I will do record. Should start recording. Okay. So what we're going to talk about today is second section of the lipids chemistry and application. And the next, and on Thursday, we'll talk about oxidation. So let's just go over something. This is talk about triglycerols. Triglycerols is the structure. And O, R1. Come in, please. R2 and R3. So this is the triglycerols. Triglycerides. And it could be mono, di, and triglycerols. Now, most of the time, if it's mono or diglycerols, we usually say we make it as an emulsification or emulsificators or emulsifiers. And if it's triglycerols, this is usually it's a food diets, which is food products. Now, what is emulsifier? This is usually it's a surfactants. Will be to decrease the tension, the surface tension between water and oil, or oil and water. And we'll talk about this later. Okay, so that's the opening remarks when we talk about triglycerols. Then we're going to introduce different type of the fatty acids coming from different resources. Now the first one, what we're going to talk is the animal depot fats. So we know that our major meat resource is pig, beef, sheep. We call it red meat, and chicken and turkey. Okay, so this is the table which tells us the fatty acids in those 5 major meat resources for our daily, let's say, meat or meal. Now, before I'm talking about these slides, you're going to have to know a little bit about these name of the fatty acids. So, 16 carbon, 0 double bonds. This is called palmitic acid. Palmitic acid. 18 carbon, 0 double bonds. This is stearic acid. These two are saturated fatty acids. Then 18 carbon, and we have 1 double bonds. This is called oleic acids. And then 18 carbon, we have 2 double bonds. This is linoleic acid. And if it's 18 carbon, 3 double bonds, well, I want to make sure it is correct. This is linolenic acid. So these basic things you need to have an idea what are they. Okay? Now first of all, when you see these meat, these animal depot fats, there is 20 to 30%, which is palmitic acids. You can see that. And the other, somewhere between 20 to 25, the others, you will see oleic acid, stearic acid is also very high. Okay, but overall you can see these animal depot fats, which is low in unsaturated fatty acids. So that's we understand. We eat meat. We not intended or supposedly we're going to eat lots of food which has unsaturated fats. But we do find, if we compare to the pig, beef, and sheep, the fatty acids in chicken and turkey, you can see the unsaturated fatty acids overall is actually higher. So chicken and turkey has a higher polyunsaturated fatty acids. You can see you add them together, it is about, let's say you have a chicken, a turkey. It is, if you add them together, you will see it is about 57 to 62%. This is called polyunsaturated fatty acids. Okay. Now, next one, I want to introduce you a very important concept. So in the industry, saturated fatty acids, unsaturated fatty acids is a very important concept because it is related to melting points typically. So melting points is a major characteristics of fatty acids. Now, how we determine it, how we determine the saturation status, they using an iodine value, which is to evaluate. Now, what's the story behind the iodine value, which is the equation right here? So any of unsaturated fatty acids, you have a double bonds. They can react with the iodine and then become, the double bonds will be break down, then each going to add an iodine there. So it looks like this. And you can measure the amount of the iodine before and after reaction. They get the iodine value. Now, for all of these animal deposit fats, iodine value is actually lower. Is around 50 to 60. Okay, so let's talk about this a little bit more. We use iodine value to evaluate, which is actually the unsaturated level and how vulnerable to oxidation. Because if it's more unsaturated, which means it's easy to be oxidated. Second, we gave you some of the example. If it's palmitic acids or stearic acids, which is saturated fatty acids, the iodine value is 0. Okay, we all know that some of the vegetable oil, let's say a very unsaturated soybean oil or soy oil, this iodine value can be as high as 130 to 150. I'll give you another example, which is the cocoa butter. Now we're going to talk lots of time during the class. This iodine value is not higher, is 30 to 40. Okay, so this in here gives you an idea of the iodine value. They use iodine value to evaluate how unsaturated it is and how they're vulnerable to the oxidation. So this is animal deposit fats. Second, we want to talk about is milk fat. Now, first of all, you need to know most of our natural fats, which is saturated, and also it's cis, which is saturated. Even if it's unsaturated, they have a double bonds. It's a cis configuration. But in the milk fat, we have somewhere 2 to 4% trans fatty acids. Now why? The reason is very obvious because of the lumen microorganism. And you can say it's a science, this simply called luminant nutrition. They talk about any of the interaction between microorganism in the lumen with the growth status of the cow or the animals. And the reason is the polyunsaturated fatty acids are partially hydrogenated, with the actual good pronunciation should call it. That's the reason the trans isomer of fatty acids in the milk fat is 2 to 4%. So this tells us in the milk products, in the milk, we do have a trans isomer, which is 2 to 4%. Then this slide, which tells you a detail of the fatty acids using gas chromatographer, how many we can find and what kind of. So this is gas chromatographer. The x-axis is time and the y-axis is the peak value. Each peak you will see, it represents one fatty acids. Okay, how many fatty acids are there? There are 60. Fatty acids in the cow milk. Actually, it's more than that. That's what we can use gas chromatographer to identify it. There is around 12 fatty acids is more than 1%. And if you look at the table, you can see it's pretty high level from the goat, sheep, and the cow milk. Pretty high level of those short-chain fatty acids. You can see anywhere between 50% even. Butyric acids, caproic acids, caprylic acids, lauric acids, and the palmitic acids, of course, it's dominant, and the stearic acids. You see, they definitely have some of the unsaturated fatty acids. Here you can see the trans is not very high. It's about 0.5 to 0.8%, which is actually lower than what we talk about here. But you see there, it definitely has a high level of unsaturated fatty acids. Now, this table here, which is using the measurement is gram per 100 gram, which is weight, percentage of weight. But I tell you, the more accuracy way to report the fatty acids component in a milk fat is using more percent, because we don't know what's the molecular amount of those fatty acids. Some of the milk products, they may be dominant with low chain fatty acids, some of them dominant with high chain. That's why we use more percentage, will be very well represent the molecular amount or molecular deposition. Now, I also mentioned that the milk fatty acids sometimes it is impossible to tell us all kinds of things, because some of the minor fatty acids, which is actually covered underneath these peak value with these major fatty acids. So we say there is a 60 fatty acids in cow milk. Actually, it's much more than that, because lots of them is overlap with these major peak value of the major fatty acids. So we don't know how many. I would say more than 80 or 100. Okay, so milk products is a very good resource for fatty acids. And you know we have a skim milk, which is 0 fatty acids. Then we have a 2%, and we have 8, and then we have a whole milk. Sometimes we have a 1%. So what is a 1 gallon bottle have the amount of the fat in a whole milk is like 8 grams if you look at the labels. So don't think about that the bottle is like 100 grams of the fatty acid. No, the whole fat is 8 grams. 2% is about 2 grams. So 1% is about 1 gram. So, okay, you can do the calculation. Okay, this is a marine oil. Now, we know about this. You can easily get 1 bottle of the fish oil from CVS. And once you see the label, they will tell you the major 2 components is EPA and DHA. Okay, what are the structure? Let's do a review what this means. If you guys still remember, we did the homework for that. What is EPA? What is DHA? What's the full name for EPA? Eicosapentaenic acids or decocyhexaenic acid. Okay, it's a very long name. We just use an acronym. What this really means? This means omega-3, and this also means omega-3. What this tells us, this is 20 carbon. Of course, it's unsaturated fatty acids. Unsaturated. How many double bonds? 5 double bonds. The first one coming from the 3rd position of methyl ends. Methyl end. Okay, that's called omega-3. This is the same thing. This is the DHA has 22 carbon, which is also obviously unsaturated. How many double bonds? 6 double bonds. And of course, start from 3rd position. Or our textbook said intervented by the 3rd position of methyl. Okay. That's methyl N. Okay. Where do they come from? Now, of course, these are cis configuration. Where do they come from? Obviously, we know coming from seafoods. Cod, fish from the deep ocean. But be careful when you get that product. Get a 1 bottle of the fish oil from CVS, you always see the bottle, it says, we were using a state-of-the-art manufacturing technique to remove mercury contamination. So there is a debate about that. Is also the fish oil extracted from those deep ocean fish, all those seafood products, that might be contaminated with mercury. And it is difficult to remove it. So there is a debate about that. People say, eat some fish oil, which is good for the heart health because it prevents the clotting of the blood vessel. But people also say the mercury is difficult to remove, to purify it. So that's a debate. I just want to let you know. And people also say, because it's a high amount of the mercury contaminated in the marine ocean area, you may good just to eat some more fish, salmon, instead of you eat fish oil. Some people will tell you about that. Another thing I want to mention is sometimes you buy a milk, which is a cow milk. They say it's a grass-fed. They will say it's a grass-fed milk. And if you look at the label, they will say they contain EPA and DHA. The reason is some of them could be reacted from linolenic acids, they generate EPA and DHA. And they use a terminology called herbivores, which is the same Herbivore, which is the same meaning of grass-fed animals. Okay? So basically coming from the deep marine seafoods or fish, but could comes from some of the grass-fed animals. Now, we use the same thing. We're using gas chromatographer. We can analyze the peak value of all these fish and marine oils. So you can see the different components. DHA and EPA is right there, and it tells us most of them is actually long chain unsaturated fatty acids, has 16 to 22 carbon atoms and up to 6 double bonds, and a huge number of that. That's why people will say marine oil, that's good for health. And lots of the research they done in the food chemistry and in the human nutrition area. However, most of the research, or we can say almost all the research, is done on mice, or in rats, or in other experimental animals, so they have not been in the clinical in the human being. Therefore, when you look at the label of these fish oils, they always say this product has not been certified or authorized by the US FDA. So it's only a supplement. It's not like really a medicine. Okay. Okay, this is Tim's major. We're going to talk about the fatty acids in the egg yolk. Okay, how many fatty acids in the egg yolk? About 36.2%, which is saturated. Left 72% is polyunsaturated or monounsaturated. What are they? Palmitic acids, oleic acids, and linoleic acids. This is, that's why every people claim themselves as a vegetarian, they still eat egg, because there's a huge component of unsaturated fatty acids compared to saturated fatty acids. Okay? You all know that egg is very cheap. You can get $1 for a dozen. Sometimes you get a coupon in the Thanksgiving holidays. You may get like 70 cents for 1 dozen. However, when you go to organic supermarkets, Whole Food, King Super, and also we have a Trader Joe's, you will get a box of a dozen eggs, which is about $3 to even $5 if it's cage-free. When you see the label, what they say? Omega-3, containing omega-3 fatty acids in the egg. Why it's expensive? Because of the feeds have flax oil. Okay, that's a key point. If you're feeding the chicken with flax oil, of course, the fatty acids components in the egg yolk will be changed. That's the reason, because the flax oil is a little bit expensive. That's why the products will be much higher compared to just the general eggs. So you usually get $3 for the general omega-3 egg. Sometimes if it's cage-free, they will get up to $5 or $6 for 1 dozen. Okay. So here you can see the feeds and the meals of the chickens. They do have some of the oils there. That is what the experiment when we did for the thermal activation. When you're using a high temperature to do the thermal activation, the oil could be floated or extracted on the surface, and those oil actually protect the bacteria for decontamination. So that's why it's very interesting to see what's going on there. Okay, this is the fatty acids in the egg yolk. Now this one will be very quick to talk about, the vegetable oil and the fatty acids. We know seeds oil, all kinds of sunflower oil, soybean oil. Of course, most of them are highly saturated. If it's highly saturated, then the iodine value will be very low, because iodine value to measure how unsaturated it is. Of course, it has a high melting points. That's the reason we're using seeds oils to do the cooking and the frying. If it's already melted, then how are we going to do it? Is that right? So that's obvious. That's why we briefly mentioned the conclusion of the vegetable oil. Okay, now we're going to talk about a little bit about the glycerols. we finished talk about the fatty acids. We're going to talk about glycerols. So what is glycerols? Okay, every glycerols, if you look at the components, what it looks like. There is a carbon in the center. Then on each side you will see then some people can draw a mirror. Looks like a mirror. Okay? Therefore, we call it CHIAL. It's chiral. That means a hand. So you put it here. Could be left side and could be right side. So L or D. Because two of the four chemicals are identical, only the position are opposite, completely opposite, under a mirror. Okay, now the chiral is very important. Because of these characteristics, we generate a terminology called enantiomers. What that means? Which means isomers generated by mirror. Now be very careful about this chiral, something else. Left hand and the right hand. If it's left hand, lots of time is medicine. If the right hand, same structure isomer, addictive drugs. So you see all kinds of movies, dramas, episodes. Some of the people are very good at chemistry. I recently watched Breaking Bad. That's an old drama. The guy is very good at chemistry. He knows all the formula. And what they can do is make a medicine, but when they change the formula just from left to right, it becomes addictive drugs. Okay, so just be careful. That's why lots of the movie, they tell you people are good at making those things. They just play a little bit tricky of these chemistry structures. Sometimes it's easy, difficult, but it is also difficult to detect it. Okay, not all the addictive drugs we have been or we have been certified it, or we have been know it. Okay, so that's something else I want to mention. Okay, glycerols. This is a talk about the chiral. Something else. This is actually